All right, good day. We begin our discussion of Chapter 3 with Section 3.1. Now, you should have the slides in front of you that I handed out in class. Chapter 3 is focusing on graphs, linear equations, and functions. 3.1 is talking about the rectangular coordinate system. We are not discussing objective number 1. We're going to go straight to objective number 2, which is plotting ordered pairs. The second and third slides goes over some of vocabulary words. You have ordered pair, origin, x-axis, y-axis, rectangular or Cartesian coordinate system. You have components, talks about the location of the points, how to find a point, and then you have the definition of coordinate, x-coordinate, y-coordinate, for regions of the graph are called quadrants, and then you can see on page 163 of the textbook, figure number 3, is a summation of all this information. But I'm still going to quickly go over it with you right here. So here we have our y-axis, and here we have our x-axis. Right in the middle is our origin. I have the first quadrant, second quadrant, third quadrant, and fourth quadrant. I will never ask you to identify a specific quadrant based on the location of a point on an exam. Just know where what the quadrants are, because I may refer to them in the notes and I may refer to them in the video or even in class. Okay. So let's try some examples. Before I move on to the examples, though, I want to show you how to plot that point that is found on slide 3, the ordered pair of 3, 2. So the steps tell you exactly how to go through plotting. You always start at the origin. It's always in parentheses x, y. It's always x coordinate, y coordinate. So x equals 3. That means I go along the x-axis 3 spaces in the positive 3 location, positive 3 direction. Then it says y equals 2. Y equals positive 2. So from that spot, now I go up to 2 spaces. There is my coordinate. Do you have to label it on a test? No, but know what it means. It's always x, y. That is your coordinate point. Okay, next we have the examples. Now I'm going to do the 4 examples that are found on slide 4 on this one Cartesian plane, just on this one coordinate system. I have questions 16, 20, 22, and 24. So number 16's coordinate point is -1, 2. So I start at the origin. Here's my y. Here's my x. Again, do you have to label the x and y axis? No, I don't require that. Just know what they mean. So -1, 2. I start at the origin. I go to -1 along the x-axis. Then up to +2 along the y-axis. So there's 16. It's in the second quadrant. Now I have number 20. Number 20's coordinate point, and these questions can be found on page 170. The coordinate point for number 20 is -2, -4. So start at the origin. I count over to -2. Now since it's -y, I count down along the negative half of the y-axis. So there's number 20. 22 is 3, 0. So x is 3. Y is 0, that means I don't go up or down, I stay right along the x-axis. So there's 22. And then 24 was 3, -3. So 3, -3. So there you have plotting points, plotting ordered pairs. Our next objective, finding ordered pairs that satisfy a given equation. There are no examples that go along with that section, but I am going to quickly discuss it in this video. You have the slide notes starting on slide 4, continuing on to slide 5. What does all the information that's presented there mean? Well, you're given an equation, 2x plus 3y equals 6. It's talking about how any real number can be selected for one of the variables in the equation above and would lead to a real number for the other variable as well. Remember, a real number can be a fraction, can be a whole number, or can be a decimal. So what it's saying is that I can have any value for x or any value for y, plug it into the equation, and I can get a value for the opposite variable. So I'm just going to spitball a few things. So let's say I make x equal 1. So in my equation, 2x plus 3y equals 6, I'm plugging in x equals 1. So 2 times 1 plus 3y equals 6 now. I simplify the expression, 2 plus 3y equals 6, subtract both sides by 2, I'm left with 3y equals 4, divide both sides by 3, y equals 4/3. So that solution for that particular equation, for that particular set of ordered pair, would be 1 comma 4/3, always x comma y. Well, what if x equals 2? I plug it in. 2 times 2 plus 3y equals 6. Simplify it to 4 plus 3y equals 6. Subtract both sides by 4. 3y equals 2. Divide both sides by 3. Y equals 2/3. So that new coordinate point is 2 comma 2/3. Well, what if I want to plug in x equals 3? Same thing. 2 times 3 plus 3y equals 6. Simplify. 6 plus 3y equals 6. Subtract both sides by 6. 3y equals 0. Divide both sides by 3. Y equals 0. Now this coordinate point is 3 comma 0. Okay, great. We did all the x values. There's more, of course, there's more you can do. Let's try y equals 1. Let's do the y value now. So I'm going to plug in 1 for y. So 2x plus 3 times 1 equals 6. 2x plus 3 equals 6. Subtract both sides by 3. 2x equals 3. Divide both sides by 2. X is 3/2. So that coordinate point, again, always x comma y, would be 3/2 comma 1. None of these examples are anywhere in the textbook or anywhere in your notes. Just keep that in mind. No matter what I do to one variable, I will always get the other variable, be it a fraction, a decimal, or a whole number. So that is why on the next slide it says an equation with two variables will have an infinite number of solutions. As long as you know one of the variables, you'll be able to find the other variable. And that again is why we say that an equation could have an infinite number of solutions. There's an infinite number of possible coordinate points that will satisfy a given equation. So that's basically what objective number 3 is discussing. Let's move on to objective number 4. Objective number 4 is actually graphing lines. So let's practice graphing some lines. So you have your notes starting on page, the 5th slide. It goes over some vocabulary words, what the graph of a line is. It gives you a picture of the equation. A first degree equation has terms with variables with no powers greater than 1. First degree equations with two variables are straight lines, so they're called linear. Equation with two variables, they can be written in the form ax plus by equals c, where a, b, and c are real numbers. A and b are both not equal to 0. So that's, in that form, the ax plus by equals c is called standard form. Now let's try some examples. So I'm going to show you how to graph 3 questions found on page 170 and 171. Oh, the last thing I want to point out is that for these problems, I'm always going to be creating a chart. So I'm going to be creating an XY table. And in the problem on the textbook, you see that it starts off with a table. So I'm going to do what I discussed in objective number 3. I'm going to take the variable, solve for the other variable, and I'm going to use these 4 points to plot my line. And that's how I'm going to solve. And on a test, I would say this is solving using XY tables. All right, so down here, I'm going to plug each number in, and then you would have to show this work. So first I have x equals 0. So in my equation for 27, x minus y equals 3, I'm going to plug in x equals 0. Okay, that just means I drop the 0. I have now negative y equals 3, which means y equals negative 3. So there's my first coordinate point. Yes, it's written as an XY table, but really you want to treat this as a coordinate point. Always have those parentheses. Next, I'm going to plug in y equals 0. This is 0, so simply x equals 3. So I plug that into my xy table. Okay, now I have x equals 5. So when x equals 5, I subtract both sides by 5. Negative y equals negative 2. Divide everything by negative 1. Y equals 2. So I plug that into my xy table. Last point, x equals 2. So I plug in x equals 2. Subtract 2. Negative y equals 1. Divide both sides by negative 1. I get y equals negative 1. So now, like I said, you have to show this work on a test for these types of problems. So here is my xy table. I'm going to plot these points, and I'm going to connect them using a straight edge. A straight piece of paper, a ruler, anything you have that you can use as a straight edge. I will not supply them in class for the exam, so if you do want to use a straight edge, you have to bring your own in class and bring your own for test day. So here's my origin. So x equals 0, so I don't move. Y equals negative 3. Now I have x equals 3, y equals 0. X equals 5, y equals 2. And x equals 2, y equals negative 1. So there are my 4 points. Now I take my straight edge, and I want to connect them in a straight line. A student might ask me, do I have to then now write the equation along the line? I had to do that in high school. No, we don't have to do that right now. I don't have to write x minus 3 equals x minus y equals 3 along the line. Not now. But when I get to dealing with systems of linear equations in chapter 4, yes, you will have to identify both lines so that I know that you're either graphing it properly or improperly and which line is which equation. But right now, don't worry about identifying the equations, writing them down. It doesn't matter. Okay, so that's 27. Let's move on to number 30. Our equation now is x plus 3y equals negative 5. So I'm going to do the same thing. Here's my xy table, the numbers I'm starting out with. First I plug in x equals 0. Okay, this drops. 3y equals negative 5. Divide by 3. I get y equals negative 5/3. Don't worry that you get a fraction. Don't worry about it right now. I'll tell you what we're going to do with that. Now I'm going to plug in y equals 0. Oops. X plus 3 times 0 equals negative 5. There we go. Okay, this drops. I get x equals negative 5. Okay, now I have x equals 1. So 1 plus 3y equals negative 5. Minus 1, minus 1. 3y equals negative 6. Divide by 3, divide by 3. Y equals negative 2. So I plug that into my table. And the last one I have is y equals negative 1. So x minus 3 equals negative 5. Add 3, add 3. X equals negative 2. Okay, I showed my work. I have my xy table completed. Now I can plot them. You're not going to plot fractions. We're going to skip that one. You will do the same thing on the exam. I don't know if the My Math Lab questions require fractions or not. I'm pretty sure I chose ones that do not have fractions, but don't quote me on that. Try the problems as best you can. If you do have problems, ask me on Wednesday. All right, so let's try. We're only going to graph the bottom 3 coordinate points. So I have negative 5 is my x, 0 is my y, 1 is my x, negative 2 is my y, negative 2 is my x, negative 1 is my y. All right, so there are my 3 points. I take my straight edge. I connect them as best I can. And there is number 30. Okay, we have one more. Question number 32. 6x minus 5y equals 30. Here's my xy table. I'm going to do the work over here on this side of the coordinate plane, so bear with me. All right, first we're going to plug in x equals 0. So we have 6 times 0 minus 5y equals 30. So that becomes 0. Negative 5y equals 30. Divide both sides by negative 5. Y equals negative 6. Okay, so that's the first number I'm going to plug into my xy table. Next I have y equals 0. So 6x minus 5 times 0 equals 30. That just drops out. 6x equals 30. Divide everything by 6. X equals 5. There's our second coordinate point. Okay, our third one is x equals 3. 6 times 3 minus 5y equals 30. So 18 minus 5y equals 30. Subtract 18 on both sides. I get 12. So negative 5y equals 12. Divide everything by negative 5. And I get y equals negative 12 fifths. So again, don't worry about the fraction. Let's just put it in our xy table. And let's do our last coordinate, which was y equals negative 2. So 6x minus 5 times negative 2 equals 30. 6x plus 10 equals 30. Minus 10 minus 10. 6x equals 20. Divide everything by 6. X equals 20 over 6. Divide top and bottom by 2, and I get x equals 10/3. So we're going to put that in our table. So just like with the previous question, I am not going to plot the parts of my xy table that have fractions. I'm only going to plot the whole numbers. So here I'm only going to plot the first two first two coordinate points, excuse me. I have x is 0, y equals negative 6. And then I have x is 5, y equals 0. And then I take my straight edge and I connect the points. So there we have the graph for number 32. I showed my work, I inputted everything into the xy table, and then I plotted the points that I could. Always plot the whole numbers, not the fractions. Okay, this concludes the first video for 3.1. This is video number 1A. Continue now, go back and look at the material for objective number 4 if you need to. Try the problems again. Follow along with me again. And then continue on to video number 1.B, which will go over objective number 5 and number 6 from 3.1.